In this video, we're going to talk about how to evaluate a combination of functions using a table or a graph. So remember our combination of functions here. We got sum, difference, product, and quotient. And so we have to think about what these functions mean, or these expressions mean, and kind of break it down step by step. So we're going to look at a table first. Notice how we normally will have an XY table. If it's a function or function notation, we've got f of x, or in this case a of x, and b of x here listed instead of y. So we've got this as our input column. I'm going to go ahead and just label that up above here. So remember, so this is input, and then these two columns for a of x and b of x are output columns. Okay. So we've got two examples here, a minus b of -2. Well, that's going to be easier to break down if we rewrite it like our previous slide here. So we want to rewrite this a minus b combination that we have as a of x minus b of x. So we're not even going to think of this -2 right now. We're just going to rewrite the a minus b. So it's going to be a of, and I can type in -2 here, a of our input -2 minus our b function b of -2. So now we can evaluate a of -2. So if our input is -2, our output for our a function is going to be 2. So I type 2 here, and that's going to be subtracting b of -2. So again, input is -2. For our b function, that gives us 9. So again, notice how -2 is the input for both a and b functions. So we're only dealing with this row here, and we end up with 2 minus 9, which is -7. Okay. Now for this other example, I'm going to make my text a little bigger. Again, we want to break this down into what we had on the previous slide. So this is a of our input 1 times, and I don't like using x for times, but just so I have something written out there, a of 1 times b of 1 is what this represents here. So since our input is 1, I can just highlight the row we're using. Input of 1, we're going to be using these as our outputs. Right? So a of 1, if 1 is our input, our output is -4. And that's going to be multiplied by b of 1. So input of 1 into our b function, and we get 4. And that's going to be equal to -16. So now for a graph, it's going to be very similar. We want to break this down into our functions. Again, try it on your own first. So it's going to be c of 3 plus v of 3. Okay. So on our c function, that's this half circle. Our input is always our x value. So at x equals 3, our y value is 4. So c of 3 is 4. And then v of 3, that's our absolute value, v here. At x equals 3, our y value is right here at 2. So 4 plus 2 is 6. Okay, and then our last example here, v times c of 4. Remember, that's the same as v of 4. Times, again, I wouldn't write this x as times. I just can't type the dot like this here. So v of 4, so now our input is at 4, so we're going along this vertical line here. Well, they both happen to be at the same point with an output of 3, so it ends up being 3 times 3, which equals